professional backgrounds, mostly in technology. And we work together to create solutions around some of the world's most compelling problems. And they include urbanization. I'll let you just read the caption so we can go a little bit faster. Migration, climate change, disenfranchised youth, and pandemics. The technologies that we use largely maybe 10 or 15, 20 years ago didn't exist or were in their nascent stages, but today have a potential market capitalization of over $100 billion. These same technologies have the potential to reach or serve the needs of 1 billion people who are in some of the world's most difficult to reach places. And they include virtual reality, machine learning, artificial intelligence, cryptocurrencies, blockchain, and data science, which we'll talk about. So projects come to us in a variety of different ways. Sometimes Chris Fabian or someone else will come to me and they'll say, I want to map every school. Who's Chris Fabian? Chris Fabian is our boss. He's the co-founder of UNICEF Innovation. We have 3 parts. We've got partnerships, which is out in California. They deal in big partnerships with big companies like Visa, MasterCard, and huge companies. I'm not really involved in that. Then we have the ventures, which is our team, which is basically startup. We come up with ideas with country offices to create solutions that they're going to need. How do we create solutions that generate insights that they can take to the government agencies? So in case you don't know much about UNICEF, and I did not before I came here, we work with governments, and in this case, we're working with governments to help them fulfill their obligation to women and children. And then the last part we do is scale, which is where once we come up with a product or a solution that gets traction, country offices like it, then it scales up, and that's out of Thailand. So sometimes Chris Fabian will come up to you and say, I want you to map every school in the world. And that's one project, and Naroa will go into that. Another project, which has been there for a while, is around data science, and it's called Magic Box, and this is an odd little diagram of it, which I will not go into. Magic Box is an open source platform designed to generate insights for humanitarian response. It's a terrible name. It's one of those things where if you're a coder, you create a variable that you know you're going to use, but you're tired and you don't know what to name it, so you just name it something. We called it Magic Box. Now, platform is a very, very odd term. I don't really understand what it means, but to me, Magic Box is a collection of repositories, and they're all modules that interact with each other, but they are also standalone tools, and that's why they get their own repository, and we'll go into that a bit later. The way it kind of works is like this. Let's say that somewhere in the world, an instance of some disease pops up, right? Some outbreak happens. Our data scientists will then work with epidemiologists to determine how that disease spreads and what data is necessary to calculate risk and forecast the next outbreak. Our next step is to work with the private sector to get that data. And then the software development team and the design team and data science, and together with the design team and with data scientists, I think all that, we all work together to create solutions. And this is one of them. So let's say that, for instance, in the case of Ebola, it's all about touch. That's how it's mainly is spread. And the question that we want to be able to ask is, let's say that you have a case of Ebola in Niani County. Well, where do you want to focus your resources? Well, most people are going from Niani to Diang than any place else. So this is where you'd want to focus your resources. Now let's say that you have another case, let's say in Masimira. Well, you'd still want to be in Diang. Let me find, there was one I was ready to do. And that's not a good one. Anyway, no matter where I touch, seems like there is where you want to go. And the way that we kind of develop these applications is, in this case, we were working with a telco in Sierra Leone, and they were giving us tower-to-tower. Let's say these are all towers, and this is not real data because we're not allowed to show you where the actual towers are. Basically, tower-to-tower mobility, which kind of looks like this. And then we translate that to admin or county to county. And I'll just show you one more thing. So this is actually a subtraction of dates of mobility. So between these two dates, you've got more people going from here to here and less people going from here to here. And I'll stop showing off now, and I'll let Naroa continue with information poverty and school mapping.
Thanks. Yeah, I'm Neuro Zurutuza, also part of UNICEF Innovation. And as Mike was saying,
big part of the work that we do, well, it's exploring different type of technologies, and one of them is around data and how can we leverage new sources of data for humanitarian purposes, etc. And one of the initiatives that we have is around access to information. So at the end, we create a lot of tech-based solutions, and we also invest in startups and all these things. But how do we make sure that the most vulnerable populations and children have access to these solutions as well, which is the other side of the coin? And an instance of this access to information is schools. Like as UNICEF, we have a big presence in the sector of education and in schools. So we have an initiative called School Mapping. And I'm going to start giving some examples of schools. I guess that everyone knows what's a school and what is it used for. So basically, yeah, it's used for education, of course, and this is a school in Brazil, in the Amazon. And in this region, schools are in very remote areas, and they are very hard to reach. Like some of them, even you have to take a boat for 9 days to get there. So in these areas, it's very hard to bring quality education, in particular secondary education, where there are not enough qualified teachers. And so here you can see a solution that has been implemented by the government of Brazil, which is education provided via satellite communication. So there is like a production studio in Manaus, the capital city, and there is a two-way communication system to the schools. And might not be the ideal solution, but at least it's better than not having anything. And this is just an example, but schools are also used for many other purposes other than education itself. And this is a school in Mauritania where WFP, etc., they use schools for their like school feeding programs and to provide food, which is very important in food insecure areas. This is Colombia, and the dots that you see over there are the emergencies that have happened in Colombia over the past year. So the green ones are natural disasters, and the red ones are violent conflict. And it happens to be that, again, schools are used as center points to respond when an emergency happens. And in order to be able to do all these things, to provide education, deliver food, etc., you need to know where the schools are first. You need to know what's the infrastructure, where they are, and then you can start delivering the services. But in many cases, even if it seems obvious, we don't have this data, and we don't know where are these points. And this is the case where you have all these maps, and you are not able to see the schools over there. So based on this, we ask the following question. Can we map every school in the world? And it's an ambitious task or ambitious question, especially in the countries where we work. So we tried different approaches to do this. The first one is to combine existing data. So as Mike was saying, we work a lot with governments. So we have access to data that the government is already collecting. So the first thing that we've been doing is trying to reach out to all these different governments and collect data that they already have and combine it, run some quality checks, etc., to start working from there. But sometimes it's not enough, so we also tried crowdsourcing. I don't know, I'm sure that you're familiar with OpenStreetMaps, their mapping programs, etc. So we had a pilot in Nigeria where we organized a mapathon where different volunteers, young volunteers came, and they mapped schools in a region in Nigeria. And this was a pilot that we explored as a way to do this. And the last approach that we are exploring, and I think this is the newest one or the most exploratory one, it's deep learning. So we have new computational technologies, we have satellite imagery. So we are trying to combine high-resolution satellite imagery and deep learning techniques to automatically map schools. So, and these are some schools in Liberia, and what we asked is there like a unique pattern of schools, such as a playground, or the shape of the building, the type of the material of the roof, etc., that characterizes a school? And can the machine learn that pattern so that we can start doing this automatically? So yeah, we did this first in Liberia, in rural Liberia, where we had some training set from the government over there. So we have location of schools that we knew that were schools, and we combined that with 1 meter high-resolution satellite imagery. And we work together with different partners, including the University of California, San Diego, Development City, Digital Globe, etc. And we got some results that are kind of promising, and now we are going to continue the work to see if it's actually like scalable and applicable. And yeah, these are some of the results. So basically, you have the map, and you divide the map in different tiles, and the machine, it's going to tell you whether it's a school or no. And over there, the yellow ones, it's the area where we tested, and the ones that are like kind of pink, they are the ones that the machine guessed properly. The blue ones are the ones that the machine didn't guess exactly, and then there are some that the machines guessed incorrectly as well. And yeah, so through this, what we want to do is to convert the empty map that we had to some map with data and information so that you can start making informed decisions based on that. And then, so once we have this map, like this is not useful by itself. We think that this is the first step to start doing things with different partners. So I'm going to give you an example of a use case that we are working with in Colombia, with the government with Colombia. And we are, so once we have that map, we went to UNICEF Colombia and we started working with them, and we asked, is this helpful for you? And they said, yeah, but let's try to like explore for what it is most useful. So we talked to different ministries, including the Ministry of Education, Ministry of Health, Ministry of Planning, etc. And what they mostly said that this would be useful for education in emergencies. So now we are working together with the Cluster for Education in Emergencies to see how can we enhance this tool so that they can use it to better prepare to these emergencies. And based on their feedback, we identified different dimensions that matter to the risk level or risk factor of a school, which are the threats, like how many threats this school or this region has, how many natural disasters have happened in the past, so what's the likelihood of another one to happen. And the same with violent conflict. Is it a region that has potential or like it's likely to have violent conflict or not, etc. And then it's the vulnerability section, so how vulnerable the populations in this region are. If a disaster happens, how vulnerable are they? Because usually the more vulnerable, then the more they'll be affected by the disaster. So within this, we are looking into different variables like the socioeconomic level, etc., and other variables as well. And the last one is the capabilities of the school itself to respond to the emergency. So if something happens, am I well equipped, or what's the infrastructure that I have so that I can better respond? And over here we are looking into connectivity, roads, how far is the closest road, is there electricity, what's the infrastructure, and things like that. And based on this, we've been working with Red Hat to build the prototype for this. So we created some mock-ups, we went to Colombia, and we also again met with the different ministries to get their feedback and see if they liked it, if they thought this was going to be useful or not. And then based on that feedback, we started creating the first prototype that Mike is going to show you now.
Okay. Sure. Ready?
Yeah, it's... Well, actually, not only the prototype, but yeah. So now Mike is going to show you the actual tools that we've been building around this.
Sure. So last week, we were all asked to speak. We had a workshop for a cohort. Basically, in addition to the work that we do in the technologies that I mentioned, we also invest in companies that do these things, blockchain, cryptocurrency, AI, VR, all this kind of stuff. And they came, and I was supposed to give a talk on how we use APIs and design, visual design or visualizations in our stuff. And I figured, well, number one, these guys are all really, really good. And number two, how we use these things won't necessarily be useful to their business models. And so I decided to change it, and I changed the topic to how to use open source to encourage external developers to contribute to your code bases. And this is sort of the same thing here. I'm not a designer. I live to design. I don't design to live. I don't know if that makes sense. In the same way that I'm vegetarian, I eat to live. I don't live to eat. I don't know if I got that right. But so that's what I'm going to talk to you guys about, open source. So for the first 2 years that I was developing software here, it occurred to me that if I'm at UNICEF and I'm prototyping applications that are designed to hopefully save lives or something like that, if I'm doing it by myself, then I must be doing something wrong. And for the last 6 months or so, myself and 2 interns, one from RIT who specializes in open source, which I didn't know existed, and another young person from Brazil, we were thinking about how we could leverage open source conventions, tools, to make our work accessible to external developers, encourage them to come on board, and if we have the configuration right, then they will have confidence that if they give us their time, it will likely result in a positive impact somewhere. And that's what I'm going to show you, sort of what we came up with. And in doing, I will introduce some of the prototypes that we created, including school mapping. So I'll start with this. So this is these top things here. So I created this slide very, very hastily. These things here, EPI, natural disasters, socioeconomic indicators, mobility mapping. These are the things that the data science team and, well, we are trying to create products around, right? The data that we need to do that are here. Here we have precipitation, population, mosquito prevalence, case data, cell tower activity, a bunch of other stuff, satellite imagery, all this kind of stuff. This is where the data lives. And these are our 2 users. Okay, this is now going to get difficult because I need my other hand. But luckily I have a lot of time, and we might have to do quite a bit of time on Q&A. Cool. So we basically have 2 kinds of users. One are, let's say, data scientists, right? And I'm going to break out of this because I didn't have the, and I forgot the, okay. Are the data scientists, and they just want raw data, right? So they just want, let's just say, for instance, let's say they're working with mobility. They just want the array of countries for which we have mobility. And actually, I can show that to you really quickly. Magic box, open, API, Azure, websites.net. And I will go to API 1, population. I think this is going to work. Countries, except I spelled it wrong. Please work. Boom. So this is what they want, right? So if they want to do mobility mapping, they want to do population. I can actually show you the. Oh, I should have this out. One second. Open maps. I'll let that load for a second. So this is what they want. Then let's say here are the countries for which we're offering population, and then you can just click on. You can choose Afghanistan, and we should get that data. And it's not really easy because it's not auto formatting, but here you would see a list of each county in Afghanistan at admin level 2, which is the county level, along with the value. And so this is my early days of design. And my purpose here was to say, okay, let's say that you want to see population by county for whatever country, use this navigation up top, and then let's say here we're showing human population. We can also show mosquito prevalence. Let's go back here, and we can scale by linear or logarithmic. Boom. And let's say that you want to click on one. Let's say, sorry, let me go back here, linear. Let's go to Turkey, because Turkey's kind of fun. So my point is, going back to my little diagram, which was before, you had 2 kinds of consumers of this information. One was the data scientists. They just want the raw data so they can go and do whatever they're going to do with it, run their models, whatever. The other kind, and I'll go back to that little thing right here, are government agencies, our partners, like RSC, maybe, if we're lucky, country offices, and the public. And they consume this information via applications. So for instance, here we are showing Turkey at admin level 2. This is population, and this is mosquito prevalence. Let's go back here. So yeah, and so how is this information served? We serve it through an API, which I can show you an actual instance of right here. This is the actual API that serves this stuff. Here's population, mosquito prevalence, case data, mobility, access control. And we also have I don't have it. Let me just go here. Give me a second to think about this. Should have this better. This one. And here's the actual code base. So anyone can clone this repository and start serving that information. But I kind of skipped one piece. So as I was saying before, and excuse me because I'm a little bit all over the place. As I was saying before, Magic Box is a platform, right? But it's also just a collection of repositories. Each of them can kind of function by themselves. However, in order to easily onboard new developers or get new external developers, we created a landing page right here that centralizes all that information. And this particular repository called Magic Box doesn't have any code, but as you'll see down here, it's got everything that you would expect in a conventional repository. So we have the about, what's here. Quick raise of hands. Who here knows what GitHub is, or just a version control service? High hands, people. Okay. And how many people have an account? How many have like a GitLabs or GitHub account? Okay. And the rest of you have no idea what I'm talking about. Okay. We're going to keep going anyway. So basically, if you're a software developer and you have a project, you are going to want to keep track of, and you're working on a team, you're going to want to keep track of who is contributing to your code base and when they did it, why they did it, and all this kind of stuff, and it would be hosted here. So I won't go too far into it. But going further, so Magic Box, here we go. So in the README, we have how to contribute. So here's your contribution guidelines, which tells you basically how to contribute, what the ground rules are, how to get started, how to report a bug, what's the code review process. And sorry, I can't remember where I was. We also have a development board, the project board, which centralizes all of our tasks. Basically, when a end user, country office, or somebody has a feature that they want us to do, this is where they go and put it. And you'll see that we have all these kind of tags. And I'll show you one. Here's one called Add Endpoint Mobility Countries. We'll click on that. And you'll see here that it has everything that you need to kind of get started on this task. Well, what is this task? It's add an endpoint, mobility countries. Why would we do it? Well, the applications need to know which countries we have mobility so that they could show those countries. And this is what the expected output is. This is how you might do it, and a little bit more in the background. Let me go back here. And then finally, sorry, I'm lost. Should have prepared a little bit more. And go back. And then finally, we have a Gitter channel where people can come and chat with us. We also have a Read the Docs that, I'll just click on it here, that has all information about, so basically like I was saying, Magic Box has, it's a collection of repositories, but we centralize all of our documentation here, and as soon as someone updates a README on one of these repositories, it automatically gets updated here. And now we'll show you a few of these tools. So, as I was saying, so data scientists, they just query the API directly. Everyone else will go through some of these apps, and I will show these apps really quickly. Q&A. Here's one of them. So this is so why I brought this up. When I was talking with, sorry, I'm all over the place. When I build this, you kind of get what the purpose of this tool is. It's so that you can see how populations is distributed in any country at a certain granularity. But when I spoke to our design team, they said actually, if a common user went here, they wouldn't necessarily know that this is mouse overable or that this is clickable. And how to navigate it. Like, let's say if I were to refresh this one more time, they wouldn't really know where to start. So the next project we did, or another project we did, was called School Mapping, which is this one. And this was designed by somebody else named Freddie Yanez, who just joined us, and he actually leads cryptocurrency. But this was his way of doing it. He just had the whole world here, and now we're actually just showing which countries have connectivity data for schools and which ones don't, but it's just a much easier way to navigate. And we'll just click here on Colombia. And so this is one of the applications that the end users use to view data that is served by that API, which I showed you before. And here we're looking at tens of thousands of schools as clickable data points. Let's get rid of this. And they're colored according to their connectivity to the internet. And so you can click on one here if you're agile. Almost got it, boom. And get the school information. One of the things that we might do next is to have a toggle between this and satellite view so that we could then crowdsource, is this actually a school? Because if you, sometimes the data could be incorrect, and so maybe you've got a data point in the middle of a field. And so there are other ways that we can improve this. And I'll show you one more. This is the product of what we did with Red Hat. So we spent around 2 months with them, all of us working in a co-working space. And again, you're looking at basically the same data set. However, we're able to underlay this data with other stuff. So on top you've got data points, and on the bottom you've got regions, here colored according to some kind of risk. So what you're looking at here is Human Development Index, but actually inverted. So here you'll see that where it's darker, it's higher risk, and this is simply where we've inverted the HDI, so that higher numbers are lighter and darker numbers are, and lower numbers are darker. We also have population. I'll undo this. Wrong one. Yeah, which is a little bit difficult to see just because everyone is huddled in Bogota. However, if we add a toggle to see this as a logarithmic scale, then you see a lot more diversity in the not so populated areas. And actually, I can show you an example of that. Somewhere here. So if we click on Colombia, you'll see that in a moment. And pretty much, what else was I going to say? Basically, all of these applications we have a GitHub repository for, which have the the last thing I wanted to show you was this. So I was showing you the GitHub repository, and I can't remember what it was. Sorry, I'll just go to it here. Sorry. What I was going to say was this repository, if you go into the public directory, you'll see that we have all the data that is mirrored over here. Messed that up. So for instance, if you clone one of these repositories and you make a query, we have a data access layer in the API that will say if you're UNICEF or if you have the right credentials, you can go in here, and if you don't, then you'll choose from a sample data set. And this just allows external developers to clone our applications and work with data that is at least representative of the actual data, because we can't give them direct access to it. And this then allows them to basically take, and this is the last thing I'll show you, take tasks from this board and start implementing them and creating pull requests. So I'm sorry, I realized I was all over the place. We're only halfway through the session. I'm pretty much out of content. Otherwise, I can keep talking, but I feel like I'm going to drive you crazy. I'm going to leave it back to Naroa and maybe Q&A.
Yeah, cool. Yeah, before the Q&A, and maybe we can have a conversation as well. Maybe I'm going to tell them a little bit about the fund. So as Mike was saying, our team, in particular, the one in New York, we work at prototyping and testing new solutions that use frontier tech, like technology that it's coming out now, that we think that it has potential to bring value, but it's not completely proved yet. So we pilot these solutions, and some of them work, some of them they don't. And as vehicle to enable this, we have an investment fund, so like a regular kind of VC fund, and we invest in startups that are in UNICEF program countries, so in emerging markets mainly. And with this, what we want to promote is also that the solutions they don't come only from us, that they are not created in New York or by UNICEF and by always the same people. So we want to promote this capacity building in these countries, and also that the solutions come from where the problem exists as well. So, and the main condition for these startups is that they have to be open source. And at the end with this, what we want is that we are creating some common good. Whatever they are creating can be implemented somewhere else, and it's open to the public also to promote collaboration among different companies and different solutions too. And for instance, just yesterday, this week we've been 3 days in a workshop where we brought the first cohort of startups from VR and AR, and then also data science and artificial intelligence. So 10 companies from all over the world came to New York for 3 days, and we spent these 3 days with them so that they could meet each other. Also, we could meet them and interact with each other. And you get to see all kinds of companies. So there was, for example, a startup from Palestine where they do natural language processing to extract information from social media so that they can send alerts to the users. And I think they work with the Red Cross and this type of users for that. There were also other companies like a startup in Mexico doing some educational gaming work and using artificial intelligence to improve the experience with the kids. And with this, so many of you also work in the field, so if you know any startup or anyone that is doing some cool stuff, there is funding that it's sometimes hard to get as well. And we do similar things with country offices. So if there is a country office that has a new idea or something that they'd like to prove, we also support them with both funding and technical expertise so that they can take this idea into, like, try this idea in the field. And I think that's it from my side. So I don't know if you have any questions. Please.
So you know the school mapping, the school maps, right?
Mm-hmm.
Have each data field which are schools. Is there like a process that you might have that updates that as you go along? Because along the way you might get new schools coming up, more schools might get closer, things like that. Is there a process to update it?
Yes, there is.
Yeah.
So I wrote an article about it, which I can show you. One of the other things that I do is that whenever I create an application or something, I'll write an article about it. And this one was called. I'll bring it up, but yeah, basically yes. So basically, all data is stored in a Postgres database, which has geospatial capabilities, and we're using what's called a CRUD, create, read, update, and delete. I think. Called Active Admin. It's a Rails application, and it has a CSV upload, and it has like a pre-import hook that checks if we already have, checks which schools we already have, and then if we have them, it updates those fields. So yeah, we do, but we get the data from all over the place. We get the data from government agencies. We get them from maybe organizations like IRC, in which case we have to kind of map the fields to the right columns because they're all different. Then we have also processes that filter out duplicates and look for other anomalies.
Are all these manual or are they automated?
Halfway, that's one of the main problems that the data comes in many different formats. So depending on what's the source, like, can look totally different. So I think that in the beginning there has to be some manual work all the time, but eventually whatever can be automated and can be generalized, then that's fine. Like it's done through a script. And I think that happens probably to all of us in all fields, right? Like sometimes with the work around epidemics, to predict the risk of epidemics, in some countries there is case, because what you need is case data, like to know where are actually the cases so that you can train the models and make them better. And this case data sometimes it's in PDFs. So then you need to start extracting the data, like making it like machine readable. And that's one of the efforts that we have as well. How can we promote that these organizations and governments start creating data that is machine readable so that programs can take it and process it more easily and without having to do it manually, which is painful.
This is an article I wrote called A Prototype to Ingest, Validate, and Serve Information for Every School in the World. It's not really that interesting. This was mainly just for the purpose of documentation. But this is just so that anyone can come on board easily and kind of see what state we're at right now. I've got other articles that are a bit more interesting that usually try to start with some kind of story or some kind of arc and then kind of just lead into code and stuff like that. So, yeah. Any other questions? Sure.
So ideally, we'd like to have all of them. I don't think that we currently have a country with big presence of refugee camps, I would say, in our focus area. But yeah, and we got, for example, also interest from UNICEF Syria country office, where they were saying that they don't know the risk of kids to go to school. Like sometimes the school is there, but maybe the roads are dangerous, or some schools are not being used for education actually. So that's a problem that we've been told that would be useful to start exploring, like start combining the data that the government provides versus what's the reality, or like what's also the situation around all this area. So yeah, and eventually. The idea is that the data doesn't come only from the government, so if there are small organizations that each of them has a set of data, then this becomes a repository where we create a comprehensive data set eventually, little by little. Because at the end, I think that the data is there, but it's sitting in many different places, so it's difficult to have a whole picture of the whole thing. And with refugee camps, we do have an initiative on trying to use satellite imagery to track the status of the refugee camps or the informal settlements, because it's not necessarily refugee camps always. But yeah, if you know there is a refugee camp, how does it, has it grown, what's the status, what's the crop around it, so what's the nutritional status of the year as well.
Any other question?
For the school mapping project, what's the satellite imagery that you're using?
For that one, we use digital globe satellite imagery. That's a good question. It's private, expensive data.
I mean, so is there anything like through UNICEF you would be able to actually get access to that?
So as UN, UNOSAT does have access to this data. We don't have that much capacity to process it at scale. So we are more used to, there is an emergency here or there is a refugee camp here, let's get the imagery and let's analyze it by hand. If you want to do that at scale, we don't have the capacity to do that. For this project in particular, we had access to it through our partners. So both of the partners had scale access to this imagery, so we took advantage of that. And then we also won, we were on one of the finalists of the Digital Globe Sustainability Challenge. So through that, we also got access to the imagery. But yeah, it's difficult and expensive, especially expensive. And even if you have it, you need to process it. So you need the infrastructure, the computing power, etc., to be able to process it.
All the training data that you collected, is that also available for someone else to use?
Depends on the country, because usually we get the data through the government. So at the end, the data provider decides how they want to share that data. If they say that it's public, then we can share it with anyone. And we want to make as much data as possible public. But depends on the provider, of course.
Sure. You, okay. In the white. You, exactly. I don't remember your name.
Thank you. In the description or the particular prototype that you were talking about, the idea came from data, big data that you had, and then you brought it to state governments, Colombia, and you said, what can you do with this tool? And that you prototyped. Is that how your projects usually start? It's a bit different from the beginning with the user.
Yeah.
And working the other way, or do they come about in different ways? And what are some other projects that are?
You want to take that? Yeah.
So your question basically is, how does a prototype start? How does it develop? How does it involve the user?
Sure.
That's accurate. Okay. Very good question. So I'm myself from startup software, so I constantly just want to see a user because that's the only way to validate if what you're doing is correct. Historically, I haven't been able to work with users as much as I'd have liked to. UNICEF and UN in general is just a really, really weird ecosystem. And there is a little bit more on the side of trying to anticipate what the user is going to want, largely because you don't have access to them because they're so busy doing stuff in the field. But usually what we'll try and do is get some kind of buy-in from someone in some program in a country office, and we'll start working with them. But yeah, not as much as I'd like to, interaction with the user. Recently, we went to Colombia where we showed them the first prototype. I won't try and browse to it. And we got really great feedback, which was phenomenal for me. One of the things that we've been doing recently is to have what we call a forward deployed engineer. I don't know if I'm allowed to talk about this, okay. Where we and the country office pay for the salary of someone who's very technical, maybe not an actual engineer, but very technical. And they're the ones who interface between us, the developers and the data scientists and product design, and the other people in the country office and the government agencies. Yeah.
And it depends, I think, case by case. So sometimes comes from, because, for example, Chris, the person that started the team, he travels a lot and he goes to the offices a lot. So if someone says that they have a specific need or problem, then we try to think, okay, is there anything that we can do to fix this? So, because I think that still there is a gap with the technical capacity of many of these country offices, so sometimes they are not even aware of what can be done or what cannot be done. I mean, of course, it depends in the office. So sometimes I think that's the way the project starts. So someone goes to a country, then someone says, I have this problem, and then we say, oh, we could do this to help you. But depends, case by case.
Yeah, it's case by case. Yeah. I think someone else had a question. Maybe not. That's true.
Hi, my name is Anne. Worked a long time in the humanitarian sector with the Red Cross. I'm new to this area, but wondering if you're seeing any shift in terms of open source, in terms of the willingness of other organizations, particularly humanitarian NGOs, to provide information that you might be able to use.
Oh, provide information as in open data?
Data. Like, are you...
Oh, yeah, you're seeing that all over the place. Oh, we're seeing that all over the place. The biggest problem is just knowing what is actually out there, because everyone's kind of doing it their own way. And so what we really need to do is figure out what the standard is. And it's probably already been created. We just need to research what that is. Because we were just talking yesterday with all the teams, basically the startups in the program countries that apply to our fund and got accepted, they're all dealing with data that we actually want to use for Magic Box. And so we're trying to figure out a really great way to search the metadata of all this stuff. And so what we need to do is really figure out what is the standard that's already out there and start using it. So in terms of open data, sure, yeah, that is. But then what we're also dealing with is just a lot of archaic, archaic's probably not the best word. I mean, we're one of the most modern organizations, you know, UNICEF, Red Cross, IRC. I know that for a fact, actually. And so how social media is changing everything is phenomenal. How open source is just kind of picking up speed. And the sooner that these organizations hire, and this is just me advocating for myself, maybe, hire software developers who understand open source, the better. Because we all speak a common language and we're all learning from each other. And I think that, so for instance, one of the things that we have here, so like I said, we have this application. Let me go back to this one here, where okay, we have 50,000 schools. Well, I also have a data set of 1,600 medical facilities. What I really like to do is see all schools that are X kilometers from the nearest medical facility. And because the repositories that we're creating have sample data sets, in this case, I'm not really allowed to show have the actual 50,000 locations in the repository. But what I did do was I went to Humanitarian data, I forget what they're called. I went to HDX, Humanitarian Data Exchange, and found a list of 70,000 points of interest for Colombia. And so I used that because you need to have data representative of the real stuff in order to run algorithms, because you don't want to do a loop. You don't want to loop between every school and every facility. You want to kind of have a smarter algorithm. So in one of the repositories, we have that as a task. And so yeah, open source is getting better, but we should. I think that UNICEF, WFP, all of them, IRC, Red Cross, we should be getting more developers. That's my opinion. Sure. Any other questions? Sure. We'll come to you next. Yeah.
Oh, thanks again.
You kind of beat her to it, so. No, please. We have time.
I think what you said about people not knowing the extent of what they can do is actually very extreme. So if I work at Harvard Kennedy School, and if I automate an email, that is sophisticated. And I don't know what I'm doing. What are ways, being as you're part of UNICEF, which is quite a traditional humanitarian organization, what are the ways that you're bridging the gap between the user needs of your people in countries in the field and what you can do, and translating that information for them and helping them ask the right questions or give you the right information so that you can help them come to understand there is a realm of possibility where we can help you with this.
Sure. I have an answer. Maybe you do too. Want to go first?
No answer. And then
I mean, just from my own personal experience in the Office of Innovation doing that. So when I first got here, my boss came up to me and he said, do you know anything about blockchain? I said, no, but I'll tell you everything you need to know tomorrow. Because I thought I would just go to GitHub and just learn it. 3 months later, I was like, I need another week. And that was back when we weren't really able to say publicly that we were exploring use cases for blockchain. But what I did was finally understood something about it. And then I saw a video called The Basics of a Bitcoin-Based Global Identity System by a guy named James D'Angelo from MIT. And it uses blockchain for, not monetary, but for something called anonymous identity, whereby you're able to reveal something about yourself, but not everything. So for instance, let's say that you're a refugee and you're a doctor. Well, you're able to, on the spot, prove that you do in fact have a doctor's degree or a law degree or whatever, but not have to reveal your name or who you are, where you come from. And so I created an application based on that, and I wrote an article about it, and I created a screencast, and that got disseminated throughout UNICEF. And so there was us sort of coming up with prototypes or examples that kind of help people understand difficult to understand technologies. We also created, I'm sort of focusing on blockchain, but that's not really all it is. We also created a blockchain, innovation blockchain snack and chat. So basically, every UN organization has an innovation unit. It might have multiple of them. And so we were coordinating with the innovation offices of the UNDP, UN Women, and a few other UN organizations. And we invited 2 experts in blockchain to come talk about it and answer questions. So that's one of the ways that we do it, is by prototyping stuff and creating narratives.
Yeah, and then to fix that, I don't know if we are quite doing it yet, but I think that we should definitely invest in this technical capacity more. So like traditionally, the UN like has nutrition specialists, education specialists, all these things. But if we are trying to create this type of work, and like traditionally we give this to partners and we like give it to vendors or like outsource it. I think that you still need to, even if you are not building it yourself, have a certain amount of people that it's going to be able to understand it and speak or have the conversations with the partners at the same level. So I think that, yeah, we really need to invest more in the capacity so that instead of being driven by private sector partners, at least we are able to sit with them and talk to them in the same terms. So that's one. And then to facilitate or enable this, we have created a UN Innovation Network, which is a network among all the UN agencies, and it's to promote this innovation, this thinking, and also create the space so that we can collaborate and people can start joining little by little. And there are more people joining, I would say.
Sure. So. Just one more thing on that. So this is an application called VIPID that was based on that guy's video, whereby if you have, I won't go, I'll send you, you can find a link later to how this actually works. But basically what we do is we take a digital fingerprint of any multimedia file and put it on the blockchain. And that's sort of and then what we did was, we used a bunch of stuff, and I won't go too far into it, but you'd be able to, if you have this on your phone, you could say 206 teddy bears, and that image of our boss will pop up that you just saw. And basically, it would verify that UNICEF vouches for you. That's basically what this application is doing. And so this was something that Chris Fabian could walk around as he was speaking with other UNICEF people and show on the spot. So this is a la Blade Runner, 1982. I'm sorry, question, sure.
This might be a little tangential, but I was wondering how UNICEF raises capital for the VC fund, and if it is funding UNICEF, how does that impact? How does that affect the kind of impact that you can have on the solutions, considering that UNICEF needs to be making money back or returns back?
So the money comes mainly from private individual donors and also governments. But so we have government of Denmark, Finland, etc., that have put quite a bit of money, and then some other private donors as well that have given money. And they all agreed to the terms. So the money is going specifically to this big pool of money that it's going to go to startups. So they are not investing in specific solutions. And they also understand that they are investing in the IP, somehow the intellectual property. So they may not get the equity back or the money investment in return, but they are getting the IP, which is open all the time, back. And I think it was the first time that the UN was moving money to a private company. So now there are more, like WFP and many other agencies also have this type of funds, but I think this was the first one that we managed to move money to a private company.
Any other questions?
How do you manage the ethics part of your project? So
like if you're mapping schools, that data is available to everyone. It also creates problems. If you were to map hospitals, like no one have hospitals that are being targeted. So like, how do you overcome that? Like, is there someone at UNICEF or the innovation department who would be like, no, this is innovation, but this is not ethical. We would not do this. Who does that further?
So the first filter, it's always in the data provider. So in the case of schools, it's usually the government or UNICEF country office the one that decides what's sensitive, what's not sensitive. So if we go, for example, to northern Nigeria, where might be sensitive to put schools out there, then of course we are not going to do that. And that's usually people that have been working in the field and have been working with the data that decide what should be public and what shouldn't be public. No, but the things that go to the tool publicly are also like there is some access permission layer that decides that. So not all the data makes it to the front end, to the visualization tool. Or in some cases, we may aggregate it. Instead of showing the actual location, we may say in this area there are 10 schools. Or depending on the sensitivity of the data, we visualize certain aggregations. And it's the same with the mobile phone data. We never make the individual data. We don't even get that data, actually. So already the telco aggregates the data for us and gives us a number that we know that it's not sensitive and it's not going to put the individual in danger. And I don't know if you want to add anything.
No, I think you. Oh, yeah, one more thing. It's just also because we're open source, you can see what safeguards are in place. And so, for instance, that app that retrieves schools from the API, you need to have an access code. And in that article that I showed you, a prototype to blah, 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 it goes into how we protect it. Sure.
So, kind of going off of that, has there been a problem with securitization of this processing fast? Have you ever ran into an issue?
I haven't yet. Nothing, no.
No, I think it's always a concern, and especially nowadays where data privacy, data security, it's an issue. And for example, with the CDRs, we do, like our researchers would like to get the CDR data for research purposes, not for actual operational things. So like to do research, then create better models, and then use the aggregations afterwards. And even that, it's difficult because of these problems. So usually we try not to get any sensitive data. I don't think we even want that.
No, we definitely do not want any personal data. So anytime we're working with telcos, we're getting anonymized, aggregated data, because we definitely don't even want it. But so there's two kinds of sensitive information. One is personal information. The other one is IP. Not IP. I'm sorry. Just private data. So, like for instance, the telco is letting us use this for good, but they don't want us to reveal where their towers are. So there's that consideration as well.
And then some companies like Telefonica, for instance, they have initiatives now where they ask the user, do you want to give for your data and for which purposes? So they can choose, like, I'd like to give it for, if it's for good or like for humanitarian purposes, yes, but if it's for whatever, no. So even these companies are trying to create, I don't know, processes that will make this more transparent. And but yeah, I think it's more a concern than actual problem, I would say.
This was a lot of fun. Oh.
Yeah. Wait. No. Yeah. Yeah.
What you explored with this data.
Mm-hmm.
It's very general data, and operationally it doesn't. I don't know how it would make sense to use it.
In the case of Ebola, the first one that we showed you, which we call carrot juice for some reason, which I can talk about later, that's just using mobility to show you where people are moving to, so you can prioritize where to put your messaging. From there, Ebola subsided, and then we moved to Zika. And Zika wasn't just about mobility; it was also about temperature. It was also about socioeconomic, because where you have poverty, you're going to have puddles, and where you have puddles in the right environment, you're going to have mosquitoes. So we're using a bunch of other different data sets. So I don't know that it's really that general. I mean, we are using data science and these data sets to inform on decision making, I think. Let me know if I'm wrong about that.
No, the questions are very diverse. Like, we've done a lot of work with mobility, how people move and try to use that for different applications. So one is the epidemic, so how the Ebola, Zika, etc. are going to spread depending on how people move, and then combining it with other data sets as well. We've done work around natural disasters, so like which populations are affected and how much after a disaster and how do they recover. And we've done that through, again, mobile phone activity. So is there an anomaly after the disaster, and then how long does it take to get back to normal? We have work around trying to estimate socioeconomic indicators using, again, both satellite imagery and mobile phone data. So are there, again, patterns on how I use my phone that can indicate my socioeconomic level? And there are many papers that show that there are. Now we are starting one around crop mapping, and we are using drone imagery to see if we can map crops and the status or the health of the crops, and then see how that's affect to the food security in the region as well. So, and I think there are more as well, but yeah. The bias in mobility, it's another one. Yeah.
I was just wondering if there has ever been, or is that a goal at some point to use a sort of before and after an intervention or during an intervention aggregation of these data sets as an indicator
Of how good the intervention for like monitoring or evaluation purposes. Okay, we haven't done anything like that, but I think that it's definitely an option. Or even like the schools or all these kind of things, if you start getting this more real-time streaming of data, you can start looking into, yeah, what's the impact or the efficiency of an intervention. But no, we haven't done anything on that.
I'm sorry, I think we have to stop because we're at 3 p.m. and
Okay.
Sylvia has to
Okay.
do her thing.
Cool.
Oh,
Good.
yeah, I'm good.
Yeah,
We're good.
cool. Thanks.
Thank you.
Thanks.